Hey team, I'm outside Cheshire Coffee and it's a little bit windy, so I apologize for any large whooshing noises. That's the wind. Okay, but welcome to our another screencast. Okay, I'm just going to jump right into it. The past couple days we've been studying momentum, and by now you know that impulse, or the change in momentum, is equal to force times time. We're going to be moving from momentum into studying energy. Okay, there we go. Studying energy. And so just as momentum had a relationship with impulse, energy has a relationship with work. Work is equal to force times distance. And the amount of work done on an object tells us that object's energy. Just like the amount of force over time, or force multiplied by time, tells the change in momentum of an object. The work, the force times the distance, is going to tell us the energy of an object. Okay, so you should know right off the bat that work is measured in joules, and a joule is equal to a Newton meter. Makes sense? Force is measured in newtons and distance is measured in meters. A joule is equal to a Newton meter. So in order for work to be done on an object, it not only needs to have a force applied to it, but it also needs to move a distance. So objects that have forces applied to them but do not move have zero work done on them. We can start out with the first example of a weightlifter right here. You can see that she is holding this barbell, and while she does have to apply a force to the barbell to keep it above the ground, to hold it, and that force is going to be equal to the mass of the barbell, so let's say it's 20 kilograms times acceleration due to gravity, so 10 meters per second squared is going to equal to 200 newtons of force just to hold that barbell in place. But there's actually no work currently being done on this barbell because she hasn't moved it, it's just standing still. So the work would be 200 newtons times 0 meters. So the work done on this barbell currently is 0 joules. So let's go from here to talking about this same weightlifter. If she picks this barbell up from the ground and raises it over her head. So now our weightlifter has done some work on this barbell. She has lifted it a distance. Let's say this distance is 1 meter. So this barbell still weighs 200 newtons. So we say 200 newtons times 1 meter is equal to 200 joules of work to lift this barbell up over her head. Now you can imagine if this weightlifter were to lift this barbell 2 meters times 200 newtons, we would see that she does 400 joules of work on the barbell. And likewise, if she were to double the weight of the barbell and lift it 1 meter, but this time the weight of the barbell was 400 newtons, she would also double from this first example the work done to lift the barbell. Okay, here's my drawing of a person walking up some stairs holding bags of groceries. So, if this person were to take these groceries and travel with them a distance of, let's say, 20 meters, and the groceries weigh, let's say, 10 newtons, they would do 200 joules of work on these groceries. And it wouldn't matter how fast this person went up the stairway. They could run up the stairway, they could slowly over minutes carry the groceries up the stairway, and they would still only do 200 joules of work in total. That's because work doesn't care about time. We saw from before that work is equal to force times distance. However, we all know that it's a lot harder to run up stairs carrying a load of groceries than it is to walk slowly upstairs carrying a load of groceries. So we have another equation, or another term. It's called power, to describe this effect of something being hard in a certain amount of time. So power is equal to work divided by the time. And you can see here in our grocery example that if we decrease the time it takes us to run up the stairs, so if we walk up the stairs or we run up the stairs, we decrease the time, and that in turn will increase the power. So things that are done fast don't require more or less work, but they do require more power. So for our grocery example, if we say we take these 200 joules of work that we do, and we do it in 10 seconds, then our power would be 20 joules per second. A joule per second is also equal to a watt, so we can say 20 watts of power. Now you can see if we half the time, still 200 joules of work, but this time done in 5 seconds. We're going to double the power required for 40 watts of power. Okay, so I'm going to write here power is equal to watts, which are equal to joules per second. Okay, so I think this concludes the screencast for today. We've talked about power, we've talked about work, and we are going to continue talking about energy over the next week. So get excited. Okay, thanks for listening.